In this video, I will show you how to find the length of the arc of a circle, like this little bold line here. How long is it? Okay. Now, the formula for the length of an arc looks like this. The arc length is going to always be some fraction of the circumference. All right, sort of snuck it in here. This 2 pi r represents the circumference. So that's the length of the entire circle, and the formula is 2 pi r. So this bold arc is some fraction of the whole circumference, and that fraction is going to be this angle theta divided by 360 degrees, all right, because that'll tell you what portion of the circle you're looking at. All right, now I'm going to just erase this, and of course r represents the radius. So right now we're going to find L, but sometimes we're going to find theta, and I'll show you how to do that, and sometimes we're going to find the radius, and I'll show you how to do that. But for now, let's substitute in everything that we know. So we're looking for the length of the arc, which I'm writing as L. Theta is, sometimes it's the central angle, and sometimes it is the arc measure. These two things are always going to be the same, so it doesn't matter whether I say arc measure or if I say central angle. Anyway, theta is 30 degrees, so I'm going to wind up with 30 over 360. Okay, times 2 pi. R is the radius. They told us the radius is 4, so I'm going to put the 4 right there. So let's go ahead and put this in our calculator. All right, let's see if the calculator will give us an exact answer just like this. So if I do 30 over 360, okay, and then I'll go times 2 pi 4. Let's see what happens. Okay, so that's 2 pi over 3. So that's an exact answer, would be 2 pi over 3. Don't forget the units, centimeters. Okay, you will lose points if you forget the units. Now the approximate answer is the decimal form, because there's rounding involved. Let's see, they said 2 decimal places, so 2.09. 2.09 centimeters. So that's it for number 4. All right, this problem still involves arc length, so I'm still going to use the arc length formula, but this time we're being asked to find the arc measure. The arc measure is the theta. That's the same thing as the central angle. All right, so we're trying to find theta. Now here's the formula again. The arc length is equal to some fraction of the circumference, which would be 2 pi r. So this is the formula. We are looking for this theta, all right, the arc measure or the central angle, same thing. So that means we must be given the arc length and the radius. We have to be given both of those things. So let's see, the arc length is 20.11, so I will put that here. 20.11 is equal to theta over 360, all right, times 2 pi times 8, okay, because 8 is the radius. So I just need to solve this for theta. So the way I'm going to do that, first I want to get rid of this denominator. So I'm going to multiply it by 360 on both sides of the equation. All right, that way this 360 and this 360 will cancel each other out. Now I need to see what is 360 times 20.11. Okay, that's 7,239.6. Okay, and that's going to equal theta times, and 2 pi 8, I'm going to go ahead and put 16 pi, because 2 times 8 is 16. All right, now let me double check because my memory is horrible. So 7239.6. Okay, so I'm trying to solve for theta, so I need to get rid of the 16 pi. So it's time for me to divide both sides by 16 pi. Okay, 16 pi. That way I can cross that out, and that's just going to leave theta by itself. So I can just put this in my calculator, and that will be the approximate answer. All right, so 7239. I just erased this, didn't I? I could have just left it. Over 16 pi. So that's going to give me 144.03. Okay, theta. All right, arc measure, angle measure, these are in degrees. So don't forget the units, but it's just degrees. So that's the answer to number 5. I want to point out one thing to you in this video. A common mistake I see on this problem when students want to divide this numerator by this denominator, sometimes they do this. 7,239.6 divided by 16 pi. And they get the wrong answer. Okay, that's not what we had right here. The problem is, if you're going to type it in this way, you have to put the 16 pi in parentheses. So 7,239.6 divided by, and then I have to put the 16 pi in parentheses. And then now I get the 144.03 that I got the other way. Okay, so watch out for that. Okay, this problem still mentions arc length, so I'm still going to wind up using the arc length formula, and the arc length is equal to some fraction of the circumference. All right, so we're being asked to find the radius. We're being asked to find r. That's what we're hunting for. That means we must be given L and theta. So what's L? The arc length is 45 pi. So let's go ahead and fill that in. So we have 45 pi for the arc length. Theta. The arc measure is 150 degrees. This is theta. Okay, so I'm going to go ahead and put 150 over 360, okay, times 2 pi r. The next thing I'm about to do is optional. I can't just put everything in my calculator right now because I have to get r by itself. So sometimes I would multiply both sides by 360. But I've got this fraction here, and I've got more steps to do. I would like to reduce this fraction as much as possible just to make the number smaller. Now, if you just multiply by 360 and then divide later by 150, you're going to get the same answer, but along the way your numbers will be much bigger and more tedious to work with. So I'm going to reduce the fraction by doing 150 over 360 and see what I get. So this reduces down to 5 over 12. So the problem becomes 45 pi is equal to 5 over 12 times 2 pi r. Okay, so I will go from here. And now I'm going to multiply both sides by 12. All right, so I'm going to multiply by 12 here and here. So that way these 12s cancel each other out. So over here I've got 12 times 45. I'm just going to leave the pi alone. So what's 12 times 45? Okay, 12 times 45, that's 540. So I've got 540 pi is equal to, now the 12s are gone, so I've got 5 times 2 pi r. Well, what's 5 times 2? That's 10, so I've got 10 pi r at this point. Now I'm trying to get r, remember, so I need to get rid of the 10 pi. So what I would do next is I would divide both sides by 10 pi. All right, that's going to get r by itself. Now, looking at the left-hand side, I'm noticing that the pi's are going to cancel themselves out. And I know that when I divide by 10, the 0 goes away. So the final answer is going to be 54. All right, but don't forget the units. The radius is a length, and another length was given to me in meters. So I'm going to go ahead and put meters, 54 meters. And that's it. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.